Welcome to another Computing with Dr. D video. This time we're going to be looking at number operations in C# in Visual Studio, and we're going to be generating a sequence of binary numbers. So first of all, let's start a new project, a console app. Press next and we'll give it a name. We'll call it number operations version 1. Always good practice to use version numbers. We'll just go next there, we click that and we create our template. Now we've got our template made. You'll see here I've used a slightly larger font, number operations, console, right line, hello. Well, we're not going to do that. We're going to obviously give it our name and we'll type that in here, and then I'll define some variables. I'll just pause this quickly, you'll see, and I'll come back with some of our variables outlined and just the name of our program. You should possibly know how to do that by now. If you don't, you can obviously copy what you'll see me enter in a minute. So you will notice hardly any change until I come back. And here you can see what I've done. I've simply given it number operations program. Maybe lowercase might have been better here. Number 1, number 2, the two numbers we're going to be operating on, I'll be multiplying them, dividing them. And since I'm dividing them, I will get numbers which are not whole numbers. I'm not going to therefore be using integers. I need to use double or float variable types here, so I'm using doubles. Doubles are long numbers and can be decimals or non-decimals. More flexible than using integers. I'm going to have a choice where people are going to be selecting which operator they're going to use, and that is my string called choice there. And I need an answer variable container to hold the answer of the two variable types. So I'll now just go and continue with this. I've added some descriptors here about the first number, the second number that's entered, what holds the answer. Now, of course, these don't get the numbers. We have to tell the user to enter a number and then take their response and put it into the variable type. So let's do that. We've got enter two numbers for your operations. Press enter after each one. And we're going to then read what they put in. We're converting it to the double variable type, the double number, and put it into number 1. And similarly, we get then we output that first number for them to verify their own number. And then we tell them to enter the next number, and we take the second number, put it into number 2, and then again, we output what the second number is. Now what I need to do is to add a sequence of operations that they can select between, and when they enter a choice, I'm going to use a switch case statement here, and then when they enter a choice, it will perform the operation according to what they'd like to do with our two numbers. So to start with, I provide them a list of operations. Obviously they should select the number operation from the list, and the first one is 1, 2, 3, 4 that they should be entering. Add two numbers, subtract the second number from the first, multiply two numbers, divide the first number by the second. Now we need to take their response, and then we need to set up a switch case kind of selection function to use their response in order to do our operation. So let's get on to that. So here we have our switch case set up. The switch case does a few things. First of all, we take their response and put it into a variable called choice here. In this case, I'm using a string. You could use an integer as well if you wanted to, since we're using numbers that they're entering, but in this case, I'm simply using, I'm capturing the character that they enter, 1, 2, 3, or 4, and I'm putting it into a little string, and then I'm reading that string. So you could actually say 1, O-N-E, and use a string. Strings are more flexible to use really than integers for obvious reasons, but nevertheless, I'm going to show you here that I've done the calculation answer number 1 plus number 2, and then right line number 1, number 2, and the answer. So at this point, I should be able to save all that. There aren't any errors, and I should be able to run our first operation, which is adding two numbers together. If I don't enter into one, I think we've got a few issues here. We need a default section in our switch statement here, but we'll come to that next. I'll do this example. I'll run the program for you to have a look at it. I'll bring it across for you. So here it is. Enter two numbers for your operations. Press enter after each one. 234 is the first number. 600, you should know the answer. Let's see if it works. Second number is 600. Select the number operation from the list. So obviously I need to enter 1. I'm not trying to crash my program. Since I've entered 1, let's see what happens. It should hit that first case that you can see on the screen there, number 1 plus number 2, and it should give me an output telling me the number 1 plus number 2 equals, and then output the answer. So let's press enter now. So it says that 234, 600 is 834. We know that's correct. So our first case works. Let's continue on with our little calculator here that we're making. I'll add the other cases in, but you should be able to get your first case going there and follow me through the program. I won't let you watch me toil through entering all of these different cases, but I'll come back to them being entered in about 1 second. And test your own program at this stage. It's always good to test your program as you go on the way through to test each of your outputs and to thoroughly test the program at the end as well. In our switch case selection here, I have 4 cases and a default. The default will be used when you do not enter in either 1, 2, 3, or 4, and it will say incorrect operation. So we can test that in a minute. Case 1, 2, 3, 4, we have our division operator, our multiplier operator. Note that that's star for multiplying, / for divide. We have our normal subtraction. Notice that we've got the subtraction symbol there. These are the plus symbols used to join the number variables to the string that we're outputting here, and they're called concatenators, if you remember that. But our actual calculation is done up the top here in our subtract, in our multiplication, in our division. Now, in case 4, we're dividing them, so the cases match up. We do also not want to confuse our users of the program. So down here, I think we need to say console read line so that we can hold the screen open for our users to have a look at. The other thing we'll check when we go back into it is if our tabs are working. These should be tabbed in, these 1, 2, 3, 4. But let's just see what happens when we run our program and start to test various elements of it. We'll save it all. We'll run the program again. And we can just put it over here to run it. I might just minimize that window a little bit so you can see clearly. And enter two numbers for your operations. We'll enter 345, we'll enter 56. Second number is 56. Select the number operation. We already added the two numbers. Let's try subtracting them. 345 minus 56 is 289. That looks fairly correct, does it not? And notice that we don't have that crash program kind of error. I have to press enter to get that. But now I'll run it again and I'll do the next test, which is the third number. I'll enter different numbers. So we'll enter a larger number this time, 234. We're doing our multiplication this time, so we'll select 3. Okay, so there's the multiplication calculation. It looks fairly correct. I've put the X symbol there for newbies to understand that it's a multiplication operation, and I haven't put the star in. When people become more attuned to programming logic, you could use that star symbol. And again, if we run it and now do our division, which we haven't tested yet, we can work out we'll do some large number and divide it by something odd like 73, and then we'll select division. You can see what's happening. 398. Oh, I randomly selected a number which it looked like, yeah, quite interesting. I'm going to try a decimal number. Let's try that. So I'm trying to generate a decimal output, obviously. So let's run it again. Again, we will select a large number and an odd number. I can't see that 51 will do anything. But anyway, we're going to make 51.3. Second number is 51.3. So it did take our decimal number. That's helpful to know. And we'll select divide. And there we have our output. Now, we could round that output off by using math round, but we won't do that right now. We can see that our calculator at this stage is functioning quite well, and we don't have that much code. You can copy this code. You've got the first number there. You've got the switch and the default there. There's your whole switch operator selection there, and the console read line at the end. Make sure all your brackets line up. Make sure your program runs correctly. What I'll do now is I'm going to enter in a different operation. I'm going to enter a fifth operation, and in that fifth operation, I'm going to generate a series of binary numbers. And you'll see that I'll ask them to enter in a different selection as well. So let's get on to that. In the meantime, you should pause this and you should get this program working with your 4 fundamental calculator operations. And then there's the start of it there. So pause it, copy this down, get it working, get your switch case working. Make sure you have a default at the end for incorrect operation. Now, before I actually get on to that next thing, I should test that, should I not? So let's test our default entry. Enter a number, so we'll enter, doesn't matter what numbers. If I entered something that wasn't a number, it's going to give me a problem, isn't it? So divide the first number by the second, but what about if I select something like T because I've hit something randomly? It says incorrect operation, so you can see that our default operation there worked by saying incorrect operation, and the program ends normally. So I'll come back then to the next part where I'm going to be adding our binary number generator. So let's get into doing that. So first of all, we need to add another line here, console write line. Now, a binary number sequence using the first of your numbers to be the final power of 2 printed. So we're going to generate a sequence, a looping through of the binary numbers, getting the power of 2 each time and outputting that to the screen. So to do that, obviously I need to select that case 5, and I'm going to again have that heading. To do the looping, I'm going to use a for loop, and inside the for loop I'm going to count from the start of the for loop using an arbitrary variable. So if I say for and then start our for loop, and if I go, it's going to be an integer to count through the loop, and I say integer I, which is standardly used in these sorts of things, I equals naught, and then I say, okay, while I is less than our first number that you entered, which we know as number 1, num1, and then we need an incrementer, and to increment through the values of I, we simply go I++. And you can see that our assistant from Visual Studio there's useful in helping us understand what's going on here. So again, it's going to write out our output, but I don't want a console. Well, I do want a console write line here actually, because I'm going to, in here, I'm going to say, okay, we're going to use this power of 2. So how are we going to get the power of 2? Well, we're going to use a thing called math power. So let's go math, and it is simply math power. So we'll go math power, and then we will, it says 2, it's already selected 2 as a value, interesting, and using the value of I inside the for loop, which is good. So we know here it seems to have a good understanding of what we're doing, and it's going to write that to the screen. Now, I don't seem to have any errors here, so let's save it and see what happens under our fifth case. It's going to have quite a bit of output, especially if I have a large number. These numbers are going to be put on every single line, so I probably want to make it a little more sensible by perhaps saying the power of I is 2 to the power of I is blah blah, and then the output. But in this case, I'm just having the output on every line. So let's try it, and we'll select number 5 and keep our program in that structure. So we'll just click in here. If I enter nothing, of course, it just crashes. So we'll just run it again, and I need to enter a number, don't I? So I'm going to enter a number. So the number I'm going to enter, which I'm going to select, will be our first power of 2. That will print to the screen at the end of that sequence. So what power will I use? I think if we go up, say, 40 lines, we'll see 2 to the power of 40. Maybe 30 would be more sensible at this point. Right. So we're going to go to 2 to the power of 30. So that's our first number. Press enter after each one. Now the second number doesn't even matter. I can just put 0 in there. So we're going to select 5, and we'll see what happens. Okay, so here we've got 2. Our sequence starts at 1. So 2 to the power 0, 2 to the power 1, 2 squared, 2 cubed, 2 to the power 4, all the way up here to the 2 to the power 30. Now, obviously, it'd be sensible to output which is the power of 2 there and show the actual sequence, which we haven't really done. So we'll try and change our program there and make it do that. So let's just go down here. And on that sequence here where it says math power, it's going to do that. But what about if we add a line here? And we'll use our concatenator there. To the power of, and then I'm going to say what? I'm going to say I, 2 to the power of I, equals, I need another concatenator there, another joining symbol there. And let's try it again. So I'm going to enter our numbers. So let's go up to the power of 20. We can go 40 this time. Obviously, you can get to a number that's beyond what the computer can work out. And we're going to just enter in 5. It's just left the old script there. So we've got here, all right, so we're starting at 0, and it's going up to the power of 39. So even though I entered 40, of course, it goes up to that number. And while it's less than number 1, if you notice here. Now, if we go to 2 to the power, say 20, you can see that 2 to the power, we can go 10. 2 to the power 10 is roughly a kilobyte up here, you see. 2 to the power 20 is roughly a megabyte. And that is actually the value of megabyte there. It isn't really a million. And then if we go 2 to the power of 30, we see here a gigabyte. And so we can get up to, terabyte if we do 2 to the power 40. So you can experiment and have a look at those numbers. We do have the output there, which is all we really need. I'm going to finish this program here. You can test it. You can put what output you want. And yeah, well, thanks for watching Dr. D's Computing, and another video will come back and we'll see you soon, no doubt. So thanks for watching.